This is an instructional video designed to assist operators who are currently using the MBT250 system from PACE or similar sense-attempt systems. The purpose of this video will assist the operator in using the specific handpieces designed to remove and replace surface-mounted components on Ericsson boards currently in production and in development. This video will concentrate on specific techniques designed to assist the operator in performing these tasks in a safe and controllable manner. Specifically, reworking surface mount components which are very large and fine pitch, the operator needs some additional techniques and some additional tools. I will go through each of these tools and each of the techniques for a series of components on a series of Ericsson boards. Before we begin with the individual techniques, let us examine our workbench. To begin, we have the unit MBT250 or similar power supply using the PACE sense-attempt handpieces. Here we have our power supply and the 4 handpieces we'll be using during our operation. We will come back to this unit later. Let us continue and examine the tips we will be using. These are special surface mount tips designed to fit one of the 4 handpieces we will be using and designed to remove all of the components we will come across during today's discussion. Additionally, we have cleaning tools, alignment tools, tip changing tools, and a pair of tweezers which will come in very handy during the operation. Additionally, we have on our workbench solder. Here I have 2 types of solder, the first being an SN62 PB36AG2, or 2% silver. This is the accepted solder wire used during standard solder techniques. Additionally, I have a 2% copper wire, which I'll be using for pre-tinning the surface mount tips. I have flux. This is a Kester SP32 paste flux, which is accepted for use in Ericsson. This is a no-clean flux with the Ericsson number MSF21029. Further on our workbench, we have a tip cleaning station. This station is designed to clean and prepare the surface mount tips before a removal technique. The flux, which I previously discussed, I'll be dispensing out of a syringe. Lastly, I have alcohol, or in this case, propanol, which I will be using to clean after my operation. Many of these items are very familiar to your workbench. One item which we haven't discussed is a fume extraction arm. Fume extraction is an important part of the workbench today. Toxic fumes are generated from both fluxes and solders and should be removed from the workbench, or else they can cause damage to the operator working on a hand soldering technique. We will talk more about this system later during the instructional video, but we'll be using it to remove the fumes during the video. To begin our operation, we will be using this 6-layer multi-layer board and be removing some chip components. The tool to remove chip components is the TT65 or thermo tweeze. This is a conductive tweezing device heated by 2 heater elements. I will first select the proper tip from my tip ready rack, install the tip using my tip installation tool, check alignment, and tighten the set screws. Please note that the set screws should be tightened only to the point where they stop moving and should not be over-tightened or else they will bend. I should check alignment here at the tip. If I notice that one tip is further out than the other, then I can adjust that with this set screw here. I will loosen it 1/4 of a turn, have vertical movement on one of my heating elements, set alignment, and turn back 1/4 of a turn. If I wish to control the opening and closing, I can do that using this small wheel here. By turning it together, I can adjust the opening of my tweezer. After we have emplaced the tip, it is necessary to set the proper working temperature. It is recommended to set a temperature of 280 degrees to begin all operations. Please note that we must also check the tip offset. The tip offset in this case for this tip is 10 degrees. When I've reached 280 degrees here, I can begin my operation. As our tip is now at working temperature, I must prepare the tip for our desoldering operation. To do that, I will use the tip cleaning station. I will first remove the built-up oxidation and built-up flux residue with the fiberglass cleaning tool. I will then shock the tip inside, assisting in pre-tinability, with the sponge tool. I will now pre-tin my tip on the inside portion using the 2% copper solder. As you can see, I have smoke buildup now blowing potentially in my face. To prevent that, I will switch on the fume extraction system. I will use the tool in a vertical manner, coming down over the component I want to remove, touching lightly against the fillets, not pulling, and gently removing the component. As you can see, in the same manner, I can remove three-legged SOT components, as well as all different types of chip capacitors and resistors. After having completed removal of our chip components, we'll now move on to the next component type, the SOJ component. For the SOJ, we will be using the following set of tips. It is important to note that proper alignment of the SOJ tips includes making sure that the two tips are parallel to each other and coplanar. Once this has been done, we clean on the inside edge of each of the two tip sides and to place my solder again on the inside edge. We are now ready to remove our SOJ component. For these components, it is necessary to place flux on the component leads before desoldering. In this way, I can assure that I've removed all oxidation and my process is rapid and safe. I place my line of flux paste along the fillets. I now come down over the component with my tip, which is properly aligned. Here it is important to note that I'm using my fingers to tweeze the device and not my hand. In this manner, I have more control and can be assured of a safe removal. I will now come lightly down over the two sides of the component and lift the component away. Please note that I have absolutely no excess heat during this process. It is possible for me to touch the board immediately following the removal. The recommended temperature for this removal is 280 degrees on most PCBs. Please check offsets for all tips. This universal tweezer hand tool is also the hand tool we're using for the PLCC components. For these components, we're using this tip type. Proper alignment of the PLCC tips includes using the tip alignment tool. This tool will be placed in the slotted edge in between the tips. I will then tighten the set screws. This will ensure a perfect square alignment of my tip. Tip cleaning is done along the inside edge of the tip, and pre-tinning is along the four inside edges of the tip. For removal of my PLCC component, I will be using this 6-layer multi-layer board. It's important to notice here that the difficulty in this removal lies in the fact that the mass is very high and I have adjacent components all around my component to be removed. If I affect these adjacent components with temperature, then I have a dangerous repair situation. To remove this component, I will first place flux around the 4 sides. In making my removal, I will come down over the tip, slightly open up the tip, press down over the component, close, hold in place until I can feel that I can lightly remove my component. It's important not to use force in this situation or I can remove a pad. As you can see, I have a rapid removal without any thermal damage to the substrate or to adjacent components. Earlier, I recommended that we should always begin with a temperature of 280 degrees Celsius. For large multi-layer boards, however, it is recommended to raise the temperature. Here I've used a temperature of 350 degrees. In this manner, I can remove the component within 5 seconds, thereby reducing the thermal influence of the process on the board and adjacent components. It is always better to use a higher temperature for a quicker amount of time than to use a lower temperature for a longer period of time. The universal tweezer hand tool can also be used for removal of PQFP components. We'll be using the same tip type as for PLCCs, but select the proper shape. First, I will put my solder paste down along the 4 sides of the component. In pre-tinning my tip, it is important that I also tin the outside edge, in addition to the inside edge of the PLCC tip, for removal of such a device. For my removal, I will come down over the component, check alignment, come down, lightly squeeze, and remove my component. The temperature difference in the board is approximately 20 to 30 degrees and no more during this very fast removal. It is important to note that when I use the tweezer to remove a flat pack, I must use the tip to grab the side of the component, thereby potentially bending the legs. In this manner, such a method is a destructive removal of this component, and I cannot use the component again. For a non-destructive removal, we'll be using the TP65 thermopick. As you have just seen, the ThermoTweeze handpiece has allowed us to remove a series of components, including chips, SOTs, SOJs, PLCCs, and PQFPs. Let us move on to other component types. For SOICs, TSOPs, and PLCC surface mount sockets, we'll be moving to the following handpiece: the IR70 high-capacity soldering iron. This high-capacity soldering iron allows us to do normal soldering or conventional through-hole and surface mount applications, as well as specialty removal techniques, which you will now see. For the SOIC components, it's necessary to select the proper fitting tip for the IR70. For SOIC components, there's no alignment necessary, as there is only one shaft and one set screw. Cleaning is done on the tip extremity. Solder is then placed along this leading edge and on both sides. For removal of SOEC packages, I'll be making a demonstration on this 6-layer Ericsson production board. After choosing which component and the proper tip, I will now flux the component on both sides. bring my prepared tip down over the component, lightly holding it in place, making sure it's coplanar, and using a slight sliding action, remove the component. Here again, we see we have a very clean and non-thermally destructive removal. Please note the quality of this removal. For the two-sided TSOP components, they are removed in precisely the same manner as the SOIC. The final type of surface-mounted component we are removing with the IR7D soldering iron is the PLCC socket. We'll be using the following tip. Please note that the tip is similar to the tip for the TP65, however, does not have a hole in the center. The PLCC socket removal tip is in place in the following manner. Please note that all tip changes have taken place when the heating element has been hot. Cleaning and preparation of this tip is now done on the outside edge. 4 sides will be wiped clean. Then, solder will be placed on the 4 outside edges. The PLCC surface mount socket is another problem area for surface mount repair. With the IR70 and the special PLCC socket tip, we can make a safe and rapid removal of this component type. First off, I will place solder cream on the inside edge of the socket, making sure that I have contact with all of the leads underneath the plastic housing. I will now come in with my pre-tinned socket tip, place the tip snugly and firmly into the socket. With a light rocking motion, I can determine when the leads have all been heated enough so that I can remove the package. After having removed the plastic frame, we can notice that we have leftover solder paste, as well as several leads which are still attached to the lands. This is not a problem. The most important thing is that I was able to remove the package without tearing up any of the lands. I can now come with my tip to begin with and simply reheat this area cleaning away the excess solder cream and the excess pads. My final cleaning will take place using alcohol and a brush and finally wiping the area clean with a towel. After proper cleaning, we can see that I have a very correct removal operation. Please note, when removing a PLCC socket package, destroying of the package is not the most important point. The most important point is that I do not damage the PCB, the lands, or the circuitry, which you can see is the case here. And finally, we now come to the most difficult family of components, the PQFP and MQFP. For these components, we use the TP65 thermopic handpiece. Here, it is very important that alignment and pre-tinning is done properly. For alignment, we want to make sure that the center spring-loaded vacuum pick, which is activated by this finger switch, has contact with the back of the component at the same time that the leading edge of the tip has contact with the leads. For cleaning and pre-tinning, we are interested in the outside leading edge. Here, it is paramount that I have a solid line of solder on my leading edge. This solid line of solder will effectively transfer the heat to all leads at the same time. This will allow me to make a very rapid and safe removal on a high-mass MQFP board. I will now demonstrate the removal of an MQFP component on an 8-layer multi-layer board. First, I will flux all 4 sides of the component. For purposes of this video, I'm only going to prepare one side, as I've already prepared the other 3. After fluxing, I'm going to increase the thermal linkage area by putting a bridge of solder along the leads. This extra step will allow me to have a very rapid and safe removal when I come down with my thermal pick tip. For pre-tinning of the side, I suggest we use the SX70 flow desoldering tool and tip, which I would just run across the leads in this manner. My pre-tinning is very rapid, and my thermal damage to the component is very minimal, as I am not staying down a long time to do this pre-tinning process. Again, I have prepared the other 3 sides in the same manner. After having done the preparation, my removal is very simple and very rapid. In this 1/2 of a second, we can understand that there's absolutely no thermal damage to the board. After removal of our surface mount component, it's necessary to clean off the pad from the old solder. To do this, we use the SX70 solder extractor with a series of flow desoldering tips. When removing the old solder from the pads, it is necessary that we do this process with the minimal amount of heat necessary and as quick as possible in order that we do not delaminate the pad from the substrate. The SX70 handpiece, with its flow desoldering tip, allows us to do this process very rapidly and very safely. As you can see, I have removed all the solder from this pad and it has remained cold. Again, the increased surface area and thermal capacity of this tip allows me to heat the pad and cool it with the vacuum at the same time. The proper technique for cleaning all surface mount pads is to come vertically down with the SX70 flow desoldering tip, start the vacuum, and flow over the lands. In this way, I get a very clean, cool process. And the same technique is used for the cleaning of all surface mount pads. For installations where it's necessary to have a non-contact method, we use the hot air jet, mini thermojet TJ65. I will now demonstrate 2 methods of replacing chip components. The first method uses the IR70 high capacity iron and wire. I will first pre-tin one pad, place my component, reflow the one end, come in with solder and my tip and reflow the second end. Another installation method for chip components is the use of hot air and solder cream. In this way, I have a non-contact installation. First, I will place dots of solder cream onto the land pattern. I then place my component using a pair of tweezers, lightly holding it in place. I approach with my directed jet of hot air from the TJ65, come away with my air, and remove the tweezers. For the installation of PLCCs, I will use the IR70 high-capacity soldering iron and one of two installation tips. The first, a blade tip, and the second, an elliptical-faced chisel tip. I will demonstrate both techniques using both tips. To begin, I place my PLCC component on the land pattern. Then, holding it in place, I fix two opposite corners. Following that, I will put flux on the side I wish to install. Then, using first my elliptical-faced chisel and a temperature of 330 degrees for this 6-layer multi-layer board, I will load solder onto the elliptical face. I will then press the elliptical face against the side of the component and slowly run the tip down the component, checking for a proper fillet at each joint. As you can clearly see, the results of this reinstallation technique compare very closely to that of the original production. For tight situations, the blade tip could be recommended. With this tip, I will load both sides of the blade face. The technique I use will be to place the bottom portion of the blade along the fillet edge and slowly move the tip down the component. For installation of SOJ components, we will be using the same two techniques and same two tips as the PLCC, as the land and lead pattern is exactly the same. For the installation of SOIC and TSAP components, I will place the component and fix 2 points on one side. The opposite side, I will put my flux down, use the IR70 iron with the elliptical chisel tip. After loading the tip, the technique I use is a belly down from the side approach in this manner. As you can see, I have uniform results in a rapid, safe, and correct installation technique. For the installation of the PQFP and MQFP type components, we will place and fix 2 points in the same way we placed and fixed the PLCC. After, we will put down our flux use our elliptical faced solder tip, load it, use the same technique we used for the SOIC, coming in from the side, slightly touching the toe of the component, and with a careful pulling motion, we see that we're depositing solder properly and evenly on all leads. For normal hand soldering in a repair environment, it is necessary to remove the toxic fumes generated during these soldering processes. To do this, the PACE fume extractor system is a self-contained 3-filter system which removes essentially all toxic fumes generated during repair or production soldering processes. This instructional video has shown you a series of repair techniques designed to assist you in working with some of the surface mount components you will see on your workbench both today and tomorrow. For additional detailed information about your paste system, please consult your operation and maintenance manual or ask your authorized paste dealer for further operational guidelines.